introduction to stoichiometry. Stoichiometry is calculations used in chemistry by scientists to determine the exact amount of product or yield in a chemical reaction if they know how much reactant that they start with. Stoichiometry is useful in industry. It allows scientists to cut costs and businesses to cut costs because it allows them to know exactly how much reactant to use, say in a medicine, to produce the exact amount of medicine that they want. An important concept in stoichiometry that you have to understand before you can do any stoichiometric calculations is the mole. And a mole is 6.02 times 10 to the 23rd anything. Number of particles, you can have atoms, you can even have popcorn kernels. If you have this many popcorn kernels, it would cover the entire United States up to 9 miles high, so it's a really huge number. Why did scientists come up with a seemingly random number? Well, think about chemical reaction. Scientists aren't sitting behind a microscope and reacting two atoms of this hydrogen with one atom of oxygen in order to form the water. It's just not a practical number to start with. So they made a bigger number, one that you can actually see and work with in lab, and they determined this number based on the number of particles of carbon-12 and 12 grams of carbon-12. So they made it so that the number was reproducible, so scientists in, say, Argentina could do an experiment and find the same results of a scientist in Germany doing the same experiment. So the number is reproducible, and it also makes calculations easier to work with, believe it or not. You can find the mass of 1 mole of anything or any element by looking on the periodic table. And this number on the periodic table is called the molar mass. And it's typically a number that has a decimal place, roughly twice the amount of the atomic number, which is the number of protons for the lighter elements. So let's find the molar mass, or the mass of 1 mole of, say, calcium. Calcium has a symbol of Ca, so when we look up here at the periodic table, we see that the number, the decimal place, which is how you recognize it, has 40.078 grams in 1 mole. So this means that 1 mole of calcium, or 6.02 times 10 to the 23rd number of atoms of calcium, has a mass of roughly 40 grams. Let's see, let's find lead. Lead has a symbol of Pb, says that it has a molar mass of 207.2 grams per mole. So that's an important unit. You have to start paying attention to units when you do stoichiometry, or you won't be able to do them. The units for molar mass, which is also atomic mass or atomic weight, all the terms are interchangeable. They mean the same thing. It means the mass of an element, 1 mole. So 1 mole of calcium has a mass of 40 grams. So grams per mole. And 40 goes up here on top of the fraction, and this 1, because there's 1 mole of it, goes down here on the bottom. We can also find the molar mass of a molecule of a substance. And the way that we do that, let's take water for example. Water has the chemical formula H2O. And so we know that this is 1 particle. So they're all bonded together, so they're not individual elements anymore, they're 1. So they weigh more together than they do individually. the way that we find the molar mass, or the amount of grams in 1 mole of water, we take the molar mass of the elements individually and add them together. So if we have, for water, we have 2 atoms of hydrogen, 2 atoms, and hydrogen has the molar mass of 1.01 if you look up on your periodic table, and you add that to the molar mass of oxygen by itself, which has a molar mass of 16 grams per mole. So when we add those together, we get the number 18.02 grams per 1 mole. There are 18.02 grams, or that's how much mass 1 mole of water has. So let's do one more example. Let's do the molar mass of ammonia. So again, when we determine the molar mass of ammonia, we're going to be finding the mass of 1 mole, or this many particles of ammonia. So the way that we do that again is we find the molar masses of these elements individually and add them together. So the molar mass of nitrogen, if you look up on the periodic table, is 14.01. And there's only one of these because it doesn't have a subscript. That means there's only 1 nitrogen. So you're just multiplying by 1. And then you add that to the molar mass of hydrogen, and because there's 3 hydrogens, you have to multiply by 3. And when you multiply, you see that this is going to be 3.03. And so when you add it together, it is 17.04 grams per 1 mole of ammonia.